Welcome to this special explainer. Today, we're embarking on one single monumental journey. We are starting right here in our own cosmic backyard and going all the way out to the absolute end of the universe.
Just think about that scope for a second. A single journey from our cosmic backyard to the absolute end of everything. It's a totally mind-bending concept, right? But we're going to break it down step by step so you can truly visualize the sheer scale of our reality. Okay, let's dive into this. Section 1. Our cosmic backyard.
Let's begin exactly where it all started. Right in the scorching proximity of our sun, we've got the hellish worlds of Mercury and Venus, followed by our own little cosmic oasis, Earth. Then comes Mars, the planet we might actually colonize one day. But past those inner rocky planets, that's where the realm of the true giants begins. We've got Jupiter acting as this massive gravitational shield protecting Earth, Saturn with its majestic rings of ice, and Uranus and Neptune, these absolute realms of freezing dark storms. Oh, and of course, let's not forget Pluto. It might have lost its major planet status, but it stands as the gateway to the Kuiper Belt, guarding the very frontier of our solar system. But what lies beyond that border?
Section 2. Monsters of the Galaxy. If we leave the safety of our solar system, we find ourselves face to face with the absolute most dangerous monsters in the galaxy. When massive stars run out of fuel, they die in the most violent explosions in the cosmos, supernovae. And what's left behind is, well, pure physical terror. I'm talking about neutron stars. These things are so incredibly dense that a single teaspoon of their matter weighs as much as Mount Everest. Try to wrap your head around that. The crushing weight and the astrophysics here completely defy human intuition. But neutron stars aren't the only monsters lurking out there in the dark.
We've also got black holes, literal points in space-time where not even light can escape. If you cross the event horizon, the laws of physics as we know them just completely cease to exist. And while these gravitational monsters are out there shaping whole galaxies, we also have mysterious strangers gliding through the darkness. Take Oumuamua, for instance, our first documented interstellar visitor. It completely divided the scientific world with its bizarre shape and inexplicable acceleration as it zipped through our solar system.
Which forces us to ask this glaring question. Was Oumuamua really just a strangely shaped comet venting gas? Or was it something else entirely? A piece of alien tech? A probe? It forces us to confront the great unknown, right here in our own neighborhood.
Section 3. The Great Silence.
So, this huge question remains. If the universe is this full of stars, planets, and unexplained anomalies, are we truly alone? Back in 1977, we thought we actually had an answer. A radio telescope in Ohio briefly broke the silence. Out of nowhere, a 72-second, incredibly strong and highly artificial-looking radio wave slammed into Earth from the direction of the Sagittarius constellation, the famous WOW signal. We've been furiously searching for it ever since, but the cosmos has remained stubbornly silent.
Which brings us to a frankly staggering number. Just in the Milky Way alone, there are 200 billion stars. And orbiting them, billions of Earth-like planets. Many of those planetary systems are billions of years older than ours. Statistically speaking, a galaxy this ancient should already be absolutely teeming with alien civilizations.
So, where is everybody? This right here is the famous Fermi Paradox. If life is so statistically probable, the universe should be loud, it should be crowded. Yet, we see nothing, we hear nothing. Our isolation is almost statistically impossible.
Well, perhaps there is a great filter. Think of it as an evolutionary or technological wall that almost no civilization can cross. It's this ultimate test that wipes out intelligent life before it can spread across the stars. And the chilling thought we have to sit with is this: are we just incredibly lucky and we're the first to survive it? Or is our greatest test still waiting ahead of us?
Section 4. Engineering the Cosmos.
Now, if a civilization does survive the Great Filter, its development becomes practically unstoppable. Astronomer Nikolai Kardashev actually built a scale to measure intelligent life based on energy consumption. Currently, humanity? We haven't even reached Type I. We're sitting at a mere Type 0.7 civilization, because we don't even fully control the energy of our own planet yet. Now contrast that primitive status with a Type 3 civilization. They control the energy of an entire galaxy. To them, we literally look like microbes.
A Type 2 civilization would already be capable of building something like a Dyson sphere.
Picture a gigantic megastructure completely surrounding a star, absorbing every single photon and providing trillions of times more energy than Earth has ever produced. Or what about ringworlds? Massive, rotating metallic rings around stars that could replace planets entirely, giving you artificial gravity and millions of times more living area. For a civilization with that much energy, space and time aren't obstacles anymore. They're a playground.
Now, what's really interesting about this slide is Section 5, Bending Space and Time.
How exactly would a civilization that advanced even travel? The answer lies in manipulating space-time itself. Wormholes, these cosmic shortcuts allowed by Einstein's theories, essentially fold space like a piece of paper, allowing you to bridge entire galaxies in seconds with a single step. And if you can bend space, well, you can alter time. Einstein proved time is relative. By approaching the speed of light or utilizing the insane gravity of a black hole, time slows down for you. 1 year in space, and centuries could pass on Earth. That is literal time travel into the future.
But what about going to the past? Well, if we went backward, we'd smack right into the grandfather paradox. Basically, if you change the past and your grandparents never meet, you are never born to build the time machine in the first place. It's a logical loop that completely breaks reality.
But quantum physics offers a truly awe-inspiring solution to this paradox: the multiverse. Under this theory, with every decision we make and every change in time, new parallel realities and bubble universes are born. A place where everything physically possible actually happens. You aren't changing your own past. You just branch off into a totally new reality. It's mind-blowing.
Section 6. The end of everything.
But look, no matter how advanced we become, the universe does have absolute limits. The speed of light is the strictest cosmic speed limit there is. As an object accelerates, its mass approaches infinity, meaning it would require infinite energy just to push it faster. Physics literally locks us inside our own bubble.
And sadly, this bubble will one day end. Driven by dark energy, the universe is expanding faster and faster. The time will come when galaxies will drift so far apart that the night sky will just become completely black. No neighbors, no cosmic views. This is the big freeze. Trillions of years from now, gas clouds will run out. New stars will stop forming. The very last stars will slowly burn out. Temperatures will plummet to absolute zero, and eventually, even black holes will evaporate. In that infinite, dark, freezing void, time itself is going to lose all meaning.
That is the ultimate end of everything. But hey, until those cosmic lights finally go out, our job is to explore the wonders right in front of us. Will humanity survive the great filter to see this distant future? What alternate realities might already exist in your branch of the multiverse? Thank you so much for taking this monumental journey beyond Earth with me today in this explainer. The adventure absolutely does not end here, though. Be sure to hit subscribe for the next big chapter as we continue to unlock the universe together.